Congruent triangles. Okay, basically you need 3 pieces of information to prove congruence. So every one of those congruent triangle proofs involves a side being equal. So if you're trying to prove something congruent, look for a side first. There has to be at least one side you've got to show is going to be equal. So the tests are, you may remember, side, side, side. So, oh, look, 2 triangles. That one's equal to that one. That one's equal to that one. Oh my gosh, the third one's equal to the third one. You beaut, they're congruent. Okay, take away one of the sides, now it becomes an angle. So that's where we get side, angle, side. So, oh, look, that side's the same. Oh, so is that one. But it can't be any angle. And that's why we write it as side, angle, side, to highlight the angle's got to be between the 2 equal sides. Or the technical name for that is, of course, the included angle. So it's got to be the included angle, that's the same. All right, drop off one of the sides, put in another angle. It now becomes angle-angle-side. So there's an angle that's the same. There's an angle that's the same. Now in this case, can't be any side. It's got to be in the corresponding position. It's got to be in the same position. So for this one, I've gone with the one opposite the green arc. So it's got to be the same one in both. The last one, which actually is a combination of the other ones. Right angle, hypotenuse, side. Because if you know both triangles are right angled triangles, and you've got a hypotenuse that's the same, and you've got one other side's the same, you in fact could apply any one of the other 3. Because you could go side angle side, because by Pythagoras' theorem, I could go and work out the third side. It would have to be the same in both triangles. And then I would have side angle side. But if I've worked out the third side, I've also got side, side, side. And then I could use trig to say the ratio of adjacent over hypotenuse is the same in both, and I've got angle-angle side. Okay. So this special one of right angle hypotenuse really is all the other ones, I guess, combined together. It's that special case if you happen to know it's a right angle triangle. Very old question. Gosh, that's even before I started teaching. That is an old question. What's that, 31 years ago? 85? Yeah, 31 years ago. All right. ABCDs are quadrilateral diagonals. ACBD intersect at right angles. DAS is the same as BAS. They want us to prove that DA is equal to AB. So I went, well, DAS is equal to BAS. That information was given to me. When I'm proving congruence, I just like to write down A so I know which piece of information. Okay, I've got an angle that's the same. AS is in both. So I've got a side that's the same. And, oh, in fact, DSA is equal to BSA is equal to 90. That's given to me as well. So I have angle, angle, side. So therefore, DA is equal to AB. Matching sides in congruent triangles. The other way some people write it is corresponding sides in congruent triangles. The reason I suppose people tend to go with matching rather than corresponding is they get confused with corresponding angles in parallel lines. But it means the same thing, because remember, corresponding just means in the same position. And so that's what matching sides are. They're in the same position. Or corresponding angles are in the same position. We're now going to prove DC and CB is the same. So we've just proven DA and AB are equal. DAS and BAS, they're equal. AC is now common in the larger triangle I'm looking at now. So I've got side angle side this time. All right. Types of triangles. Isosceles triangles. If I know the triangle is isosceles, I can say AB is equal to AC, equal sides in an isosceles triangle. I can say angle B is equal to angle C, equal angles in an isosceles triangle. If they have not told me, this is what I was talking about before, if they have not told me it's isosceles, they might have just said angle B is equal to angle C. To save time, if I don't want to prove it's isosceles, the alternative way I could say is, well, look, AB is equal to AC. And the reason I would put down is not that they're sides in isosceles triangles, but I would say the sides opposite equal angles in any triangle are equal. and use that theorem instead. That saves me proving they're isosceles. And you could do the reverse as well. If the information they told me were the two sides were equal, then I could say, well, these angles are equal because the angles opposite equal sides must be equal. Equilateral. All three are equal. Now, notice in my reasoning, I didn't put equal sides in an equilateral triangle. I don't need to say equal sides because they're all equal. So I just say, well, there's sides in an equilateral triangle. Same with the angle. I don't need to say they're equal angles. They're just the angles. And they're all 60 degrees. All right, some triangle terminology. Altitude. It's just another name for perpendicular height. Okay? And in fact, there's going to be 3 perpendicular heights in any triangle, and they will meet. Median. The median is the one that joins a vertex to the midpoint of the opposite side. Median meaning middle. And again, if you were to draw all 3 up, they would meet at the same point. The other one, right bisector. So it's at right angles to the side, but comes from the midpoint. So that's what we call a right bisector. Yeah.